Do you hear me all right? I guess that's a yes. Okay, my name is Jelinek, and I work in the Solaris kernel group. I'm one of the development engineers on the zones team. I'm going to be talking today about using zones and containers to do application consolidation. I gave a talk yesterday on built-in virtualization for Solaris, and I was wondering if I could real quick maybe get a show of hands how many people, or if anybody attended that talk, because I have some overlap in material from that talk yesterday that I could kind of skim through or skip over if people have seen that. So if you were at the talk yesterday, the built-in virtualization, could you raise your hand real fast just so I could see? So actually most people didn't go to that talk, so I'll try to cover some of the upfront material. I will go over that then. So let me just start by saying what we're going to do here is I want to talk a little bit about zones and containers and give you a sense of how you can use those to do application consolidation, give you a sense of the strengths of zones and areas where you may want to think about using other solutions. So here's the agenda. I do have some background material up front. I'll go through that real quick. If you were at the talk yesterday, it'll be a repeat of some of that stuff, but for the people who weren't there, I'll cover that real quick. And then we'll go through a bunch of the different features of zones and kind of, I'll try to highlight specifically how you would use those to do consolidation. So real quick, people have been talking about virtualization and consolidation a lot lately. Why is this important? Well, what's happened over the past maybe 10 years is it's been common in enterprises to deploy each application stack onto its own standalone system. And that was okay because systems, x86 in particular, those systems were very inexpensive. And so what you wound up having was a server sprawl situation in your data center where the average utilization on a lot of those systems was really low in the 5 maybe to 15% range. Over time, as other costs have become more important, that begins to outweigh the benefits of the cheap servers and just deploying every stack on its own system. So nowadays, with power and space costs and cooling costs and so forth, those are becoming more of a factor and sort of pushing the trend back in the other direction, not to deploy so many systems. The other side of the coin is that the systems themselves have become a lot more powerful, so it becomes even more of a waste when you're maybe using even just less of a percent of that system to deploy your stack. And virtualization has now become a mainstream technology. So we're basically looking at a situation where it makes a lot of sense to try to consolidate and pull those disparate applications back onto a fewer, more highly utilized systems. So some of the benefits, aside from consolidation, which is a key benefit in terms of your cost and so forth, once you actually take that application stack and sort of virtualize it up off of the hardware, then you can do other things with it. It makes it easier to move that application around, to redeploy, so you have more agility in how you're actually managing all of the different things in your data center. You can clone those apps. You can move them off to another site. When you bring new hardware in, it's easy to sort of rebalance everything. So actually lifting those application stacks up so they're not working directly on the hardware gives you a lot of the benefits that we talk about here on the slide. I always want to talk about why OpenSolaris, just in general, is a good platform for virtualization. And really the things here on the slide you can see are key factors when you're looking for the foundation that you're going to build your virtualization sort of platform on top of. You want to have these attributes. So being able to really scale to support a large number of CPUs and large memory configurations, that is important once you start consolidating these multiple workloads onto a system. You want to have a reliability, which you have with Solaris with FMA and SMF for the hardware and software side of things. You need virtualized storage solutions, which we can give you with ZFS and Comstar. Now with Crossbow, the new networking technology, we basically have network virtualization, which is really beneficial, not just for containers, but also for full hypervisor virtualization. being able to observe into what's going on using tools like dtrace. All of this stuff is really important technology and really sets, I think, OpenSolaris apart in terms of being a foundation for virtualizing. So this is a slide we use all the time, so you might have seen this many times, basically sort of showing the spectrum of the virtualization solutions that we have and kind of where they fit. Over here on the right, we have resource management. And in general, I'm not going to talk much about resource management at all, because what typically happens, this is the traditional sort of capability that you have where you can essentially apply controls and limits and things to a particular application. The problem with resource management is it doesn't provide enough isolation once you start bringing these different stacks onto the same system. So really, when you move to the center with operating system virtualization, which is what Zones provides, that basically gives you not only the ability to do resource management, but also the isolation in terms of avoiding namespace conflicts, and it gives you delegated administration and things like that. So really the combination in the center of operating system virtualization with Zones combined with the resource management features, it really is where you get the virtualization solution we'll talk about here today. Further over on the left, you start looking at virtual machines with hypervisors where you're actually running multiple different kernels on top of a hypervisor. I talked some about that yesterday. We won't be getting into that today. So we'll concentrate really on that middle area where you're running a single kernel with the isolation provided as a primitive by the kernel itself. And so because you're only running one kernel and you're always running in a zone, whether you realize it or not, you basically get the high efficiency and the scalability of running the single operating system. So basically, what is a container? Hopefully people are at least somewhat familiar with this. Zones, which is really the foundation of containers, have been in Solaris since Solaris 10. We've continually been enhancing them ever since that release. Basically, what this is it's the primitive that provides you that encapsulation and the isolation so that it looks like you're, in a sense, running your own individual operating system within the container. You can boot it, you can reboot it. You have your own configuration files within the container. You have the namespace isolation, so if two applications want to open up the same port, that's all virtualized and isolated so that there's not going to be any collisions. So it looks a lot like each container is its own operating system, but really you have only the one underlying kernel. So you do get the scalability and the performance that provides. So here's a picture, kind of a sort of an old one, but it basically shows kind of what you would see with the zone. And what you can see is that the global zone, which is really the base operating system, sort of is the outer box, and it's running its own services, has its own namespace, file systems, things like that. Within that operating system, we actually have two zones that are running side by side. One up here you can see is called the red zone, and the other one is called the sun zone. And if you actually look at and study the picture, you can see that you're running, in terms of Apache, one of the zones has a different version than the other. They can both be sitting on the network, listening on the same port, and that virtualizes out so that they're going to get their own networking traffic. They have their own IP addresses. On the network, they really look like their own independent systems. You can actually log into these and reboot them, configure them the way you want, run different services within each one, and then you can see how the file systems and the storage space actually gets provisioned into each of those zones. So they have their own. In this case, like shared user and shared opt, and working off onto the storage provided by the global zone. So some of the things when you're looking at zones and containers, you want to think about the trade-offs of when this is a good technology to deploy versus using a different solution like a hypervisor solution. In terms of the pros of containers, really, when you start looking at a virtualization thing, you probably want to always start by considering a zone as your first option, because that's going to give you the best performance and the best scalability. It's going to give you the best observability. It's going to be the lightest weight approach to doing a virtualization and a consolidation solution. Basically, because it's a primitive of the operating system, it runs anywhere that Solaris runs. So it runs on x86 and Spark. It runs on Sun 4V and Sun 4U Spark architecture. So, anywhere that you can run OpenSolaris, you can use zones. It's a mature technology. As I said, it's the best scalability and performance. We have the capability to run brands, which I'll talk about later in the presentation. So even though there is only that one underlying kernel within each container, you actually can have different environments, a user-level environment like a Solaris 8 or a Solaris 9 user-level environment inside of that container. Some of the cons to think about when you're looking at zones is if you need support for different operating systems beyond what we support with the brands that we have, that's going to rule zones out. So Windows is an obvious example. If you want to run Windows, then you really have to start looking at a hypervisor solution because we don't have support for that inside of a zone. We do have a Linux brand that allows you to run Linux in the container, but we really only support like the 2.4 version of the Linux kernel, and so it's a little bit dated. And so if you really want to do a bunch of Linux stuff, you might want to think about going to a hypervisor-based approach. But so that's something that would be a little bit on the fence. You'd have to kind of look at in terms of if the container would be the right solution or not. The other thing as a con really is if you need to actually have different kernel patches for one container versus another, then that's going to basically be a limitation for you, because since there is only one kernel, you can't patch it to different levels. Obviously, that doesn't make sense. So you really would have to look at something like a hypervisor where you're running different Solaris kernels above the hypervisor. And then there are a few limitations currently on containers. The biggest one probably that we have today is we can't be an NFS server inside of a zone. That's not a fundamental limitation. It's just a limitation on the current way that NFS works, and hopefully we can relax that in the future. But there is a few limitations like that could direct you away from containers towards some other alternative. So here's a quick summary. I'm not going to spend a lot of time on this, but basically this is just a summary of some of the features that we've added to containers since they were first released with Solaris 10. Some of the highlights, Brand Z, we'll talk more about Brand Z during the presentation. You can see that I have a couple things marked in red there. In terms of OpenSolaris itself, the Solaris 8 and Solaris 9 brands currently are only available on Solaris 10. They haven't been ported to OpenSolaris yet. The Solaris 10 brand is actually an active project that we're doing on OpenSolaris today. So it's not integrated into OpenSolaris yet, but I have the project page there. On OpenSolaris.org, we actually have an active project. It's open source, and it's under development right now, that people who are interested in that could actually participate or run the code as we're developing it, or do whatever you want to do as part of the open project. One of the other things I do want to point out, we'll talk more about, is an update on attach. Is something maybe not everybody has heard of. I'll go into that in more detail on a different slide. P2V, or physical to virtual, I'll be talking about that too. That's not yet in OpenSolaris. We do have that integrated into the base Nevada code, and we should be getting that feature into the OpenSolaris code base. Hopefully within the next week or two, I can get that integrated. In terms of a backport, P2V is not yet available on Solaris 10 either. I'll try to if there's differences between like what's in Nevada, what's in OpenSolaris, and what's in S10, I'll try to highlight those as we go through, just to give people the context of not just OpenSolaris, but also S10. So that's a little bit of background. What I want to do now is I'm going to start actually kind of going through the different aspects of containers and kind of trying to talk about the things that you want to think about and do when you're actually doing consolidation into a container. And so the first and most important thing is you really need to be thinking about and using resource management. So by themselves, zones provide the namespace isolation and the security that you need, but unless you actually turn on some resource management features and use them in conjunction with your zone, you might not get all the containment that you're really expecting. So it's always critical that when you configure your zone, that you configure it with a certain amount of resource management set. So in general, what I recommend to people, we'll see a different alternative on the next slide, but as a default, if you're not doing dedicated CPUs and things like that, you always want to really be using the fair share scheduler, because what that's going to do is it's going to make sure that as you have multiple zones on your system, that one zone can't hog all of the CPU resources of the machine. So really, in almost every case, I would say your system should be set up to use the fair share scheduler if you're going to be using zones on the system. That would sort of give you a good default behavior if one zone goes out of control and starts consuming a lot of CPU. The other thing you want to do is you always want to set the max LWPs, which essentially limits the number of lightweight processes that the zone can do. And so I've actually shown that here in the example in the center. The first line there basically is setting up so that the global zone, the fair share scheduler, is the default. So if you would do that, then that switches it over so it uses fair share. And then on your zone configuration, you can see that I'm setting the number of shares for that zone, and I'm setting a limit on the max LWPs to be 1,000. So what that's going to do is that's going to limit that zone. It can't have more than 1,000 lightweight processes, and that zone is going to get 5 shares. So if you had multiple zones running together in one zone, by default, if the system is idle, that one zone can use as much CPU resources at once. But if you have all the zones and they have a lot of work to do and they're all, the system essentially becomes saturated and all those zones are competing for work and competing to be scheduled, that's when the fair share scheduler is going to kick in and make sure that each zone is getting the share of CPU resources it needs. So you can think of the fair share scheduler under normal conditions when the system isn't saturated. It's not really doing anything special for you. The one zone that's busy can use the whole system if it wants to. But when all the zones are busy and the system doesn't have enough CPU to keep up, that's when the fair share scheduler is going to kick in and make sure each zone gets its share. The other thing to be aware of is that you can combine the fair share scheduler with CPU caps, which I'll show you on the next slide. But basically, that's the inverse of what fair share does. Fair share kicks in when the system is fully busy and has more work to do than it can complete. Basically, at that point, fair share gives everybody the share they need. CPU caps is the opposite. It'll stop the zone even if the system could give it more resources. So basically, it sets a limit on the amount of CPU a zone can use. Normally, you would use CPU caps in a situation where, let's say people are buying CPU time. If they buy one CPU worth of time from you, let's say, for that zone, then you want to limit them to only one CPU, even though you're running them, let's say, on a 64-way box. If they've only bought one CPU, then you could set a CPU cap, and basically they won't be able to get any more resources. You could also use CPU caps to basically set user expectations. If you know you're going to be consolidating more onto that system later on, and you don't want your users to get used to a lightly loaded system because you know later it'll be more heavily utilized, you could actually use CPU caps to artificially limit the performance of a zone in that way. So the other thing you can do with resource management is basically, this is a little bit more sophisticated. You can actually do capping and dedicating of memory and CPU. So basically, in the top there, what I'm showing is an example where you can actually do what we call a dedicated CPU configuration, and we've set up so that there's a range of 1 to 5 CPUs available to that zone. So what will happen is when that zone boots, it will actually be allocated a number of CPUs in that range, and it will be the only zone that can use those CPUs. That's different than the normal behavior where the zone can use all of the CPU resources on the system, as I was just describing in the fair share case. In this case, you've been allocated a number of CPUs, and you'll just have those for your exclusive use. Dedicated CPU is particularly useful like in a licensing situation. Say with Oracle, if you want to run Oracle in a zone and you have a 2 CPU license, you could put that in a zone and set the number of CPUs equal to 2, and then you won't be violating your Oracle license agreement even though you're running it on a 64-way box, for example. The other thing you can do here is I'm showing is you can set up a capped memory configuration. Basically, what we're doing here is setting upper limits on the amount of memory that this zone can use. You can see you can set up to 3 different properties. You don't have to set all 3. You could just set one if you wanted. You could set a physical memory limit, let's say, and not set the other 2. But in general, it's always a good idea, I would say, to set up a capped memory limit for the zone so that it doesn't use too much memory, in particular when you're doing a consolidation type thing and bringing those workloads together. Finally, here on the bottom, I'm showing an example of the capped CPU that I was just talking about on the previous slide. And you can see that you can actually do granularity of CPU allocations down to actually hundredths of a CPU. So in this case, what we're doing is we're saying that in that bottom example actually, it's a little bit, I have a typo in there, but basically it's limiting it to a quarter of a CPU. Moving on, in terms of networking, the networking model with zones, there's two ways that you can do networking. You can do what's called a shared stack or an exclusive stack. The shared stack is the default behavior for a zone, and what that means is that the global zone manages the network configuration for the zone. So when you boot the zone, the global zone actually will set up the IP address, plumb the virtual interface, do all the routing. Inside of the zone, you can't actually then control that and manage it. You can't change it within the zone. So that actually gives you a level of security where the root inside of the zone can't go off and like maliciously change things around. That gives you a good level of security and encapsulation inside the zone if you're managing with a shared stack. The alternative is to actually do what's called an exclusive stack and give an interface to the zone and let it manage all of its networking just as it would on a standalone system. When you do an exclusive stack, then inside of the zone, they'll actually plumb the interface and configure it. They can change the IP address. They can do their own routing, all those sorts of things. With an exclusive stack, you do have to dedicate a NIC to the zone, which can be a limit up to now because most systems don't have enough NICs to dedicate a physical NIC to each zone. But with Crossbow, as I mentioned and you've been hearing about while you're here, that really solves that problem because now you can actually set up virtual network interfaces using Crossbow and then just dedicate a physical VNIC to the zone. And then if you wanted to actually do exclusive stack and have 100 zones on your system, each one could have their own dedicated VNIC. Finally, in terms of networking, one other thing to be aware of is the default router property. Basically, with that, when you're using a shared stack, that allows you to actually, that's now the global zone, remember, and the shared stack is managing all the networking. And if you have multiple interfaces and multiple routes, basically the default router does give you the ability to control how the routing for that individual zone will take place. So here, this is showing an example on the bottom, basically, of how to set up an exclusive stack. You can see that you set the IP type. Remember, it defaults to shared. And then when you set up the network configuration for that zone, all you have to do is set the physical device that zone should use. And in this case, what we're showing is that it's going to use a VNIC that you've set up in the global zone. As I said, I'm going to kind of go through all these different features, so we'll just keep moving along, changing our pace here on each slide pretty much. Cloning is the next thing that you would probably want to be aware of in terms of a zone feature. Basically, what this allows you to do is this is an alternative to installing a zone. Basically, with cloning, what you can do is you can set up a single zone, put all the software in it, do all the customization and things, and then once you have that ready to go, you can just clone it as an alternative to installing the second zone. Basically, this has been integrated into zones for a long time. It does leverage ZFS if it can. So, I mean, if you're familiar with ZFS, you know ZFS has cloning already. With zone cloning, basically what it'll do is it'll copy the zone if it's not on ZFS, but if everything is on ZFS and both zones are in the same Z pool, then what it'll actually do is it'll snapshot and clone using ZFS. And you can see the example here in the middle. I've actually provisioned this second zone. It took 6 seconds to actually set it up. So basically, you can use cloning and snap zones off really quick as an alternative to actually setting them up and manually installing each one. So you can see once I did that, that second zone is now in the installed state. So I mean 6 seconds is a pretty fast way to provision a new virtual environment. Some of the other ZFS integration that we have with zones, we automatically create the data set. So when you're on ZFS, we see that you're on ZFS and we do automatic data set creation. You can do what's called a delegated data set. So you can actually, as part of the zone configuration, give a ZFS data set to the zone for it to manage itself within the zone so it can do its own ZFS snapshotting and cloning, the things that Ben was talking about earlier. So setting up a delegated data set, you can see here you basically just use the add data set resource and then give it the name of the data set you want to delegate. And then once you log into the zone, you can see that you now have access to that data set. So you own it. From that point on, you can make new data sets underneath it. You can make your own snapshots and clones underneath it. You can basically manage it as you want. One of the nice things about this is in the global zone, you actually can set quotas on these data sets, which is not overridable inside the zone. So if you want, you can actually set up a data set, delegate it to the zone, and within the global zone actually set up a quota which says, I don't want this to grow any larger than 10 gigabytes or whatever your quota is. So within the zone, you can do everything you want up to that quota. So basically, that's not overridable inside the zone. Let's see. The other thing that you can do is you can actually use the zvol support, which is essentially looks like a block device on top of ZFS. And instead of adding a data set, you can actually create a volume and then add that using the add file system or add device in this case. So you have a lot of different options to get ZFS devices into a zone. You can build your zones on ZFS. You can delegate data sets. You can configure zvols. So there's quite a bit of integration that you can leverage there. Moving on to migration. Basically, this is a capability to take your zone once you have it set up and running on a system and move it to another system. We don't support live migration, so the zone has to be halted when you're doing this. But then you basically can transfer that zone image over and boot it on a different system. We've had zone migration for quite a while, but one of the limits, if you've looked at zone migration, is that the source and destination system really had to be in sync because of that single underlying kernel. But what we did is we added this capability called update on attach. And basically what that allows you to do is during your migration from one system to another, you can actually update that zone so that it's in sync with the underlying global zone. And so you don't have to worry anymore about the source and target being in sync. We can actually update the zone to match the new target. I'm actually showing in this example here on a S10 system because that's a little bit maybe more interesting in the sense that you can see what's happening is we've figured out all the SVR4 packages that are installed in that zone that have to be updated. We actually clean out those packages. We don't clean out any of the data associated with the packages. So, you might think of it similar to an upgrade in the sense that the configuration files and so forth are preserved, but the new binaries are actually then updated inside the zone. So that box in the middle that I've highlighted kind of shows you the work that's happening to update the SVR4 packages. And really that amount of work is related to the delta that you're going across. So if you're taking a zone and moving it from one system to another, and those two systems only vary by, say, one patch, that amount of work that happens there in the middle, it might be one package that's getting updated, and it only takes a moment. If you're going across, let's say, from S10 update 5 to S10 update 6, then there's a lot of packages that have to be updated, and the amount of work there in the middle is actually much larger. This does also let you move across architectures on the Spark side of things. So it does handle the fact that you can go from like a Sun 4U system to a Sun 4V system. This same capability sort of handles that. We have this also within OpenSolaris. It's obviously not using SVR4 packages in OpenSolaris. It's using IPS. But basically, you can do the same thing. Take a zone and move it, and use the update on attached capability, and that'll work with IPS to update the IPS packages to match for that zone to match what's installed in the global zone. As far as the actual moving of the bits, we leave that up to the sysadmin because there's a lot of different ways to do that. It's not built into zones itself, so you can actually get that zone over onto the target system in whatever way works best. You can, copy the bits. If you have a SAN, you can reconfigure the SAN so that the target machine can now see that zone. So however you want to get those bits available on the target, you do that work, and then you can use this feature to actually get the zone attached, basically we call it attached, onto that new target. So next I want to talk a little bit about branded zones. Actually, I'm going to take several slides to talk about this. So branded zones basically is a technology we added a few years ago, and it really is an extension to the zone infrastructure to allow us to run different user level code inside the zone as compared to what's running in the global zone. And our first project we did this for was with the LX brand, which allows you to run Linux user land inside of the zone. So what we did is we extended the zone's infrastructure with a bunch of different hooks and things so that we can do the kind of interpositioning and emulation that we need to do. You still have only that one. Remember, there's only the one underlying kernel, so you still get the same performance and scalability benefits that provides, but there's sort of a thin emulation layer that you now can use with the branded zone to go through and actually run these different user lands. So each one of these is called the brand, and we have LX. We have a testing brand, which we call the SN1 brand, if you look at the Solaris source. And then we built the Solaris 8 and 9 brands were the next projects really that use this to allow us to run on Solaris 10. We can actually run Solaris 8, the Solaris 8 user land or the Solaris 9 user land. So basically, I said that we've added this kernel infrastructure in these interpositioning points throughout the kernel when you're working with the zone, so that you can emulate on system calls, loads, forks, things like on the proc file system and so forth. We have all these hooks, so depending on what you want to do with that particular brand that you're implementing, we have the interposition points to be able to do the proper emulation. I'll actually walk through a little bit of how that works. So you basically, the process of building a brand, you sort of figure out where you have to do the emulation, and then you just do that and nothing else. So you still get all the same performance for the things that aren't emulated. The emulation itself is really lightweight, so you're not paying the same kind of penalty that you do when you're going through like a hypervisor and a virtual machine and the whole kernel. You're actually doing just a little bit of emulation to use the underlying Solaris kernel functionality. So here's an example kind of how this would work, and I'm actually going to point a little bit here. So what you have over here on this side is you've got your global zone, and normally what happens is when it makes a system call, in this case it's doing an open system call, and it's trapping into the kernel. Now, normally what will happen is it'll actually just use the normal open and just return. But once you boot up a branded zone, this interpositioning comes into play in the kernel, and this actually gets dynamically patched into the kernel once the branded zone boots. So normally there's no change at all, but as soon as that zone's running, this gets patched in, and you can essentially see what happens here is that this code is going to look to see if it's a branded process, and if it is, it's going to do something else. Otherwise, it does the normal system call and code here and then returns. So once a branded process comes in over here, you can see with the LX zone now, it does an open system call, and it comes in and says, oh, this is a branded process, so I'm going to use the Linux brand module, which actually just redirects back out to the user level code to the emulation that's actually linked in to that process. It gets linked in behind the scenes when the process starts up. So the emulation is actually out there in user land doing whatever it's doing. So you can see that that emulation can actually trap back into the kernel and do its own open using the native code, or it could do some other work and actually return directly to the process, maybe going through the kernel, maybe just returning back to the process address space. So that gives you a sense of how that brand emulation actually could work for a particular system call. So the LX brand is the first one we did, but like I said, it's maybe not the most interesting one. The Solaris 8 and Solaris 9 brands are the next big ones we did. And, a common question is, why do we need those brands? Obviously everybody, or hopefully everybody knows that we have a lot of compatibility with Solaris in terms of application binary guarantee and all of that. So, we provide all that compatibility, but the problem is that the application stacks in reality sort of oftentimes go beyond what is provided by the actual application binary compatibility. So, you can have things in your stacks, like in your installers, might be hard-coded to look for particular versions of the operating system. You might have scripts that depend on command line output formatting in certain ways that change from one release to the next. There's a lot of sort of undefined things once you move outside of what the binary compatibility guarantees that you might be depending on in a complicated application stack. And, sort of figuring all this out and understanding, will this application work correctly on the new version of Solaris? At a minimum, it takes a certain amount of time to do that validation and verification and things. So really what this does is it allows you to sort of bypass all that and run those apps using these, in this case, the Solaris 8 or Solaris 9 user land. They're using all the libraries they've been using. They're using all the commands. All the command output is the same. So you basically have that environment that gives you full compatibility beyond the strict binary compatibility. Another reason you might want to use these brands is if you're actually building applications, you have to build on the oldest release you want to deploy on. So if you supported S8, let's say, although that's pretty old now, but let's say you wanted to build your apps so they would run on S8 and later, you can't compile them on S10 because we don't support going backwards in time, only forwards. So since you have to compile on the oldest release, you could actually compile your apps in an S8 branded zone and then release them and make them available on S8 forward. So, there's a lot of different reasons. There's just the fear of if it's not broken, don't touch it. A lot of different things like that make it interesting to have these brands. So when we were looking at this, kind of the motivation for us was we came up with this concept that people I think are familiar with, the long tail. And really it's the long tail of the data center. There's a lot, in some enterprises, thousands or tens of thousands of these old systems. They're poorly maintained. They're running kind of a lot of old standalone stuff. Really, so the idea here is that this is the optimal area, this long tail of being able to take and consolidate all of those things onto new modern hardware and get rid of that old hardware that's probably not supported anymore or maybe breaking down. You can actually consolidate it and bring it together on modern hardware like, let's say Spark systems, the CMT machines, where you can run, which are an ideal platform really to consolidate onto because they have so many threads and large memory configurations. So that's really kind of the motivation for consolidation is that long tail area there when you're talking about the S8 and S9 brands. So what we have as part of the project that we did there, we built this P2V or physical to virtual utility. It's not really a utility, it's more of a process. The idea is that you can basically take that standalone system and archive it up and then move it into a zone without having to, actually, reconfigure the system. You just, tar up or flash archive the system, and then you can install it into the zone running on S10. It's basically just a zone install once you have that archive, and at that point you're running that full system stack. Whatever was configured on that original system is just re-replicated into the zone. So to do that, basically, with a Solaris 8 branded zone, here is an example. You basically just go through the normal zone config. You can use the create -t there to basically set up the brand type and set up the other zone attributes that you need, and then you would set up anything extra that you want, your zone path and any resource management settings in zone config. And then to actually do the install or the P2V, what really happens is you just have an install option. You give it the path to the archive that you created of that system. So that's the -a and the path there. And then basically the -u says, I want to sys unconfig that. You don't have to sys unconfig it. You can preserve the system identity if you want. But basically that's the P2V that you're seeing right there, is you're just installing that archive into a zone. It goes through, and now that zone is ready to boot. So here's just a little bit of a marketing slide. It's actually a little bit dated because it's talking, I think, about some of the older hardware compared to even what we have nowadays. But you know, it gives you a sense in terms of consolidation of the kind of saving that you can realize by taking some of those older systems that are running those standalone application stacks and consolidating them together onto a single system. Actually, probably getting comparable performance here. In most cases, and you can see how much you would save in terms of space and cooling, and in addition, the actual support costs for the hardware itself. So the other thing that's interesting about the branded zones here is that you know, now that you're running, in this case on Solaris 10, you're actually making those new Solaris 10 features available to those old environments. So you know, because your underlying system is Solaris 10 in this case, and your global zone is Solaris 10, you have things like dtrace, so you can actually dtrace those old S8 and S9 apps. They can reside on ZFS. You have things like FMA, which gives you the higher reliability than you had with those older operating systems. You know, so you have all the new features of the operating system that are now being made available to the old OS that's been hosted inside the zone. So the next thing we did is after we built those brands, we started working on the IPS project, which is, hopefully everybody knows, is the new software management system that's being developed for OpenSolaris. And so what we did is we actually are using the brand infrastructure to support that project. Now, we don't have to do any of the kernel emulation that I was just talking about. This iPackage brand that we're creating here is really a strictly user-level thing where we're using just the hooks that allow us to plug in and be able to do our own software management, installation, migration, things like that. So we don't actually have to do any kernel emulation or anything like that. We're just using the brand Z hooks really to do our software management operations now. And that gives us an easy way to sort of do the development work that we need to do to switch over from using the SVR4 package system to install zones and upgrade the zones and so forth. And now we can actually use those hooks to plug in and do those software management operations with IPS. So some of the things that you should be aware of with zones on OpenSolaris is because they're using this iPackage brand, right now it's whole root only, which is, if you're familiar with zones, really means that you're not allowed to use any inherited package DIRs, or what we call a sparse zone. We only support whole root zones because the IPS packaging system itself does not support the concept of the sparse zones like the SVR4 packaging system does. Other things to be aware of with OpenSolaris is because IPS actually talks to the repository to download the software, you have to be on the net today to install zones. We do things a little bit differently. We actually install sort of a minimal set of packages into the zone. It's about 55 right now. So your zone is actually pretty small, maybe 150 megabytes approximately. But what you do have to do then on OpenSolaris is if you need to run your app, if you need any additional software, you have to install those extra packages into the zone to add the stuff you need. Some of the other things, if you've played around with OpenSolaris, what you'll know is that uses this concept of the boot environment, or BE Atom, to essentially, when you're upgrading, let's say from the release from last year, the 2008-11 release, if you want to actually upgrade to the 2009-06 release, basically when you do the package image update of your OpenSolaris system, it works in conjunction with the boot environment manager to set up a new boot environment, and that's integrated with zones so that those zones will actually get cloned into the new boot environment. Each zone has its own ZFS data set on OpenSolaris, so the cloning happens as part of the whole BE Atom management process and image update. There's some limitations there. One of the things probably I should highlight is that zones on OpenSolaris are still kind of a work in progress, just like OpenSolaris is. So there's still limitations and things that we're in the process of developing. So just so you know, I mean, zones aren't as polished as they are on Solaris 10. And if people are using zones on OpenSolaris and you have any questions about it or things like that, we could talk afterwards. You can always email me too, because as I said, there's still things that we're working on. Probably the last thing I should highlight here is that it's not fully integrated yet with the package image update stuff. So we'll actually create, when we make the clones, we'll actually, the zones will be cloned, but the IPS software itself does not yet update all of the zones. Basically, it doesn't have the concept of these dependent environments yet. So that's hopefully something that we'll fix for the next release. But you'll see in your boot environments that all your zones will be there on the new boot environment, but you actually have to manually update each one of those to sync it up to the global zone right now. The easiest way to do that is really using the update on attach capability to just detach and reattach your zone. So moving on, P to V, I mean, this was one of the things that we developed when we were doing the Solaris 8 and Solaris 9 brands. And so the logical thing there is let's generalize that capability so that we can do physical virtual for native zones, just like we could do with the Solaris 8 and Solaris 9 brands. So, really the only limitation there is that we need to keep that image in sync. So when you take that physical system and bring it into a zone, it has to match what is running in the global zone as far as the kernel. So we actually leverage the update on attach work that we did as part of the P to V process. So when you bring that image into a zone, we do an update on attach on it to essentially sync that system up to match the global zone. So it works a lot like that earlier example I was showing you with the S8 and S9 brands. Basically, you make your archive in whatever way you want, you bring it over, and then again, that example should look exactly like what we saw before, where you basically just give it the path to your archive, and it installs the archive into the zone, and then unconfigures it, and you're ready to go. So we have the support for native. That, as I mentioned earlier, it's not quite in OpenSolaris yet. That should be showing up in OpenSolaris in the next couple weeks, hopefully. And this has not yet been backported to S10. Hopefully we'll get that backported to S10 update down the line. Basically I mentioned it's not backported yet. It does work with sparse zones on native. So in the S10 world with SVR4 packaging, you can actually take a physical system and bring it over, and if your zone is configured as a sparse zone, it handles that properly. The other thing, when you're actually doing this P to V process and taking a physical system and bringing it into a zone, one of the things you may want to take advantage of is the emulated host ID. So if you had software that was locked to a particular node, and now you want to move that into a zone, you can use that host ID, set up the emulated host ID like I'm showing in the example there, so that that zone looks like it has the host ID that the original system had. Continuing on with this brand work that we've been doing for several years, the next step that we did, or we're in the process of doing right now, really is the Solaris 10 brand. So what this is going to allow you to do is actually run the Solaris 10 userland on OpenSolaris. So it's very similar to what we did with the S8 and S9 brands, except now it gives us S10 running on OpenSolaris. So that gives us a nice sort of compatibility environment, so that if you have a bunch of apps or they're all certified and running on Solaris 10, but you want to leverage the new features that are in OpenSolaris, you can actually run OpenSolaris as the underlying OS and get the new features like Crossbow and some of the other things you've been hearing about here this week. But within the zone itself, you're still running the Solaris 10 environment that you were running on the original standalone system. We have a P2V that works with this brand just like we've been talking about. So again, you can take that physical S10 system and bring it forward and drop it into the container on OpenSolaris. Also, because Solaris 10 supports zones, but you don't have the ability to nest zones within zones. What we did is we have a virtual to virtual capability, which allows you to take those zones off of the Solaris 10 system and bring them forward and run them as Solaris 10 branded zones on top of OpenSolaris. And as I mentioned, at this point, this is an actively developed project. It's not integrated yet, but we have code that works. You can actually download the source from the project page there. You can run it on your system. If you're really interested in it, you can actually help us out to build the brand. So, I mean, I kind of went through a lot of different features really fast here to think about in terms of consolidation and what you want to do when you're doing consolidation with containers. Some of the things just to highlight the limitations a little bit that you want to think about when you're doing consolidation using containers. The key thing probably is the one kernel. So, again, if you need to be able to have kernels at different patch levels, that may be a limitation that's going to be a problem that would steer you away from using containers to do consolidation. Some of the other things, probably the people who are doing consolidation or running zones on their system, probably the biggest problem that they're running into today is related to patching. Because patches have to be applied to all the zones, and this is an S10 thing, not an OpenSolaris thing, because OpenSolaris doesn't have patches. But on S10, because the patches have to be applied to all of the zones, performance can be a problem just because it takes time to do that. But we recognize that that's a problem, and we've been actively working on it. So we do have in Solaris 10 Update 8. Coming down the line, the ability to do parallel patching, and we've made some other changes to the SVR4 packaging code, which will actually speed this up a whole lot. So if you've actually tried to do some of this in the past and found that patching was a problem, in particular when Update 8 comes out on S10, it might be worth taking another look at, and hopefully we've addressed a lot of those limitations there. I mentioned earlier about NFS server. That's probably the biggest sort of other thing that we currently don't support that tends to hold people back from using containers to do consolidation. Some of the other storage technologies also yet don't work inside of a zone, but those are less critical, usually like iSCSI Target or a CIF server. NFS is probably the biggest one. And then just the last point is, there's certain privileges that just aren't available to apps running in a zone. It's part of the security and containment that zones provide. So, if you have an app that wants to read kernel memory or install its own device drivers, things that I've highlighted there, then those really are not the appropriate applications to try to consolidate into a zone. You can combine zones, I do want to point out, with some of the other virtualization solutions that we have on OpenSolaris, so it's not an either-or type thing. So because zones run anywhere OpenSolaris works, if you're running Solaris in a hypervisor, say on top of XVM or LDOMs, you can always put your zones on top of that. And conversely, you can put a VirtualBox inside of a zone. So that's actually beneficial if you want to use a VirtualBox, let's say, to run Linux or Windows, but you want the containment that Zones provides, in particular around the resource management area. That's a good combination, because essentially what you can do is, you can put, let's say, Windows in a VirtualBox and then put that in a zone and then use the resource management, maybe do a capped CPU resource and say, I only want that Windows instance to use 1/10 of my CPU. And so that gives you an easy way to sort of combine the resource management features of Solaris with something like VirtualBox. So here's some URLs that you can go off to. I mean, probably the best one is the bottom one there. The zones community on OpenSolaris.org is probably the best place to go to find all of our design docs, our project pages, our discussions. That's probably your best resource. So just to wrap up, I do want to reiterate again, the features that are in OpenSolaris really make it a good platform, a good foundation for doing virtualization, not just with containers, but also the other options that we have with the hypervisors. So remember, we have the lightweight environment with zones. I mean, you're going to get the best performance and scalability. You get the best observability because you're running that single Solaris kernel. With branded zones, which is the new thing that we've been working on for several years, you have a lot more flexibility with zones now because you can run the different user level environments within the zones, and the P2V work and things that we've done allow you to really mix and match and do a lot of interesting things when you're doing consolidation into a zone. So I think we've added a lot of features to zones over the last couple of years that really help to simplify the whole idea of doing consolidation this way. I think I'm actually right at the end of my time. I don't have any fancy demo. I was just going to show a little bit about doing some zone cloning. And
it turns out we don't really need to reset.
oh, okay. Let's see. Well, this was my so I can real quick. We could either do some Q&A, or if people, I can do a little bit of demo stuff here. You can actually see on this system. I'm running. I'm running OpenSolaris, and I actually have our development bits installed here. So I'm running the Solaris 10 branded zone. Actually, I can shift over in this tab, and I'm logged into that zone right now, so you can see. Actually, just to show again, this is just the S10 zone that I have running. I did a little bit of demo stuff yesterday where I was actually showing. I have my directory mounted into this zone, so I can actually share. Let's see here, if I remember how I have this set up. So I actually have, if you can see here, I have this is my OpenSolaris window right here. I actually have, so you can see it's running OpenSolaris, the 5.11 OpenSolaris release. I actually have a little demo program here that I was showing yesterday, basically a little C program that just prints the version. Now, if I wanted to actually develop this on OpenSolaris, I couldn't really ship this on Solaris 10 because I have to be able to compile on the oldest release I'm going to support. So I can actually come over here. I have the same, because I have my directory mounted into this zone here as well. I can just, you can see it's the same program here. I can just compile this on Solaris 10 and run that little program on Solaris 10. And now it's a Solaris 10 program that I could actually release that same binary on OpenSolaris, and you can see that it behaves appropriately. You can extend that concept to the full application level if you'd like. So the other thing, just looking real quick here, you can see that I have I have the iPackage branded zone, one of those installed here. So real quick, what we can do is we can actually create another zone here, and I'll show you some of the zone cloning. So what I'm going to do is actually I'm going to just take that, I'm going to just replicate that same zone configuration for this new zone here, and I'll go ahead and set the zone path to the new place. And so now you can see that I basically just sucked in that first zone configuration. So I basically got all of the resource management settings that original zone had. I have that all I replicated that right in here. So now I have, you can see that I have two zones defined. I have the first one, and then I have the one I copied that configuration. And so now what I'm going to do is I'm going to just clone it, and basically, if everything goes well, this should just take a few seconds. So basically now I have, you can see that that zone is now installed and ready to boot up and go. So you can see that it was just that fast for me to take and suck in that first zone configuration, replicate all the settings it had, clone it, and now it's ready to boot and go. So, I mean, that's a little bit, just real quick, showing some of the capabilities that I've been talking about. I won't do a P2V. I mean, we could do a P2V and everything, but those do take more time, mostly because it's copying a lot of bits into the zone and things. So, we don't really have time to do that. But that just gives you a little bit of a sense of the kind of things that I've been talking about. So, in particular, if you have any questions about it, I try to blog every so often about some of the work we're doing, or I'm always on our project page on OpenSolaris.org if you have any questions, or if you want to participate in the project, the S10 brand project, or just give us any feedback. You can always send me an email directly, or just ask questions on the discussion list on OpenSolaris.org. So with that, is there any questions? Well, so the question is, going forward, will zones expect IPS to be present? And really that depends on what you're running as a distribution. So, today what we have is on the SXCE distribution and on S10, the native zones basically expect SVR4 packaging to be there. So if you wanted to have a zone that didn't use SVR4 packaging, you would have to build a brand for it. What we're doing going forward with OpenSolaris is the OpenSolaris project is essentially moving Solaris in the direction where IPS is the software management system that manages the system. And so we're essentially tracking zones along with that so that they can do software management using IPS. So if you wanted to, let's say, take the source code from OpenSolaris.org and build your own distribution that wasn't using IPS, you would either have to build a brand like we're in the process of doing today, or so we're also looking at essentially how we can generalize a lot of the software management as part of the whole IPS project, so that it's easier for zones on different distributions to provide essentially their own software management without even having to build a brand, to sort of kind of deal with the fact that you might have a distribution that uses SVR4 packaging or a different distribution that uses IPS. So we're actually actively thinking about how we can generalize all of the infrastructure so that it's not so the packaging is sort of separate, and each kind of distribution could provide its own mechanisms for dealing with software management of zones, kind of independent of having to build a particular brand. So I think what you'll see probably in the next 6 months as we continue to develop these ideas as part of the OpenSolaris project, you'll see new designs coming out, new projects where we're actually sort of breaking that connection so that it's not so much a part of how the zone is implemented with a particular brand, but it's more of how you want to build your distribution. Any other questions? I know we're kind of running right to the end here. And so I think maybe we're out of time. So if anybody does have any questions, I'll be kind of hanging out in the back for a little bit and stuff. So feel free to come up and ask me anything.